Okay, in this video I'm going to continue on with my tutorial series on thermodynamics and statistical mechanics. I'm on video number 11 and this one is, we'll say, independent, however it's very important for some later proofs, and this is the proof of Stirling's theorem or Stirling's approximation, which says the natural logarithm of an argument is equal to the argument multiplied by the natural log of it minus the argument again. So to be honest, this is very much a back and forth thing. The proof is, I like the proof because it's quite smart actually. So we'll see how we get on. So it's basically about observations and comparing things and realizing that in actual fact you have the same thing written in two different ways. So let's note something. Let's note the following derivative. If we take the derivative with respect to x of the natural logarithm of x, we simply get 1 over x, and if we take the derivative with respect to x of x, we get 1. So let's apply the chain rule and get the derivative with respect to x of x times the natural logarithm of x. I'm not going to explain the chain rule, so we get, or not the chain rule, the product rule, excuse me. I'm not going to get that, and we get the following here, the natural logarithm of x plus 1. So remember, we're trying to get x times the natural logarithm of x minus x. So what if we try and get the derivative with respect to x of x times the natural logarithm of x minus x? Let's see what we get. Well, we're going to get the natural logarithm of x plus 1 minus 1, or the natural logarithm of x. So we've now found a way of we've now found an expression which, when differentiated, gives the natural logarithm of x. Alright? So, is there any way we can use that? Yes. Well, by taking the following observation. If we in fact take if we take an integral, so let's say we integrate this side dx, and we take this, integrate this side dx, what do you get? Well, if we do that, we find that the integral of the natural logarithm of x dx is equal to x, the natural logarithm of x, minus x. Alright? Now, compare that to what we have up here. We're saying that the natural logarithm of x factorial is equal to x, natural logarithm of x, minus x. Here we have x, natural logarithm of x, minus x, is equal to some form of an integral. So the question is this: what can we do with this particular integral? Is there anything? Let's go ahead and evaluate the integral. So I'm going to note what we are after seeing, that the integral of the natural logarithm of x with respect to x is equal to x natural logarithm of x minus x. So let's go ahead and evaluate this between 1 and n. So we're now evaluating this between 1 and n. So the steps here, we get n log n minus n minus the log of 1 plus 1. That's equal to 0, so we kill that, and then we're going to get n, the natural logarithm of n, minus n plus 1. Now, we're talking about large numbers, that's why it's an approximation. So if we're talking about approximations, we can kill this 1 and we get n log n. N log n minus n. So what we can say here now is that the integral from 1 to n of the natural logarithm of n dx is approximately n log n minus n. But here's the tricky, not the trick E, but rather the trick. The trick is to analyze this integral geometrically, or to interpret it geometrically. So let's say the natural logarithm function does something like that. Right? There's the natural logarithm of n, and on the x-axis we have n. So let's look at this as more of a Riemann sum. Right? So if these little, let's say we have these little segments, each of these segments, let's say, is broken up into width w, and we have all these different segments. Okay, so another way of interpreting this particular integral is by saying that the integral is equal to the natural logarithm of 1 times w, that's the area, plus the natural logarithm of 2 times the w, plus the whole way up to the natural logarithm of n times w. So take out w for the moment, and we're going to get w outside of the natural logarithm of 1, logarithm of 2, plus the whole way up to the natural logarithm of n. Knowing your rules of logarithms, if you add natural logarithms, it's the same as multiplying them inside one particular logarithm. So this is w outside of the logarithm of 1 times 2 times 3, the whole way up to n. Well, sure, what's that? None other than the factorial, so w, natural logarithm of n factorial. Alright, and where w is the width of the block of the approximation. So the whole point of this is we can now make Stirling's approximation. In Stirling's approximation, the integral from 1 to n of the natural logarithm of x dx is equal to n log n minus n is equal to natural logarithm of n factorial. So from now on, if you see the natural logarithm of n factorial, you should immediately write down that it's approximately n log n minus n, where in the large limit, or in the limit of large numbers. Alright, so thanks for watching. Please pass it on to your friends, subscribe to my channel, and if you're in a good mood you might also click an ad. Thank you.